So today what we're going to talk about are inverse functions. And some of you have heard or learned about inverse functions before, but we're going to review these in a little bit more in depth, in detail today. So an inverse function maps the output values, which are my y's, back to their original input values, which are my x. So we'll talk about what that means in just a second. But basically is the output values maps back to their original output values. So your domain, which we know is our x, of the inverse relation is the range of the original relation, and the range of the inverse function is the domain of the original relation. So what does that mean? It's really confusing the way that it's written there, isn't it? Basically, it just means what you have for your x becomes your y of your new inverse function, and your original y becomes the x of your inverse function. So they basically do one of these, and we're going to talk about an example really quick. So if you have an original relation, original ordered pairs, and we can graph these to get a line or whatever function. If this is your original relation, then its inverse relation means that all the x points become the range or the y of your inverse relation, and your y values of your original relation become the x values of your inverse relation. So you're swapping your x's and y's between your original relation and your inverse. So you're swapping your x's and your y's, which means you're swapping your domain and ranges, the list of those values. More importantly, the graph of your inverse relation is the reflection of the graph of the original relation. And this line of reflection is the y equals x line. So we're going to be flipping your x's and your y's, which is shown to you in the three graphs given to you at the bottom of your page. So if your original relation is here, alright, so you've got 1, 2, 3, 4, 5 points. And we're going to call those green points. So we're going to highlight them really quick in green. Those original points are going to reflect over your y equals x line, which we know is the line that's 45 degrees that cuts in a positive slope between your quadrants 1 and 3. So your original points, which are the green ones, so I'm going to highlight them in green real quick. Those were the original green. They're going to swap now, reflect over your y equals x. So again, this is when you take them and then you're going to be flipping them over, so kind of like folding over that the pink line. So this one is equidistant across, so we get the orange dots that become our inverse relation. So we're flipping, graphically that just means we're flipping over our y equals x line, which is a 45-degree angle that slices through positively in our quadrants 1 and 3. Okay, so that's what it means graphically. To find the inverse, we don't even necessarily have to do this graphically every time, but to find the inverse of a relation that is given by an equation in x and y. So now we're looking at the equation. All we're going to do is we're going to switch the roles of x and y to solve for your y if possible. So really what we're going to do graphically is we flip over your y equals x line, but when we look at our equations, we're just going to swap x and y at the beginning and then solve for y. So let's look at example 1. In example 1, they want us to find the inverse of the relation y equals 2x minus 4. So the very first step, so this is our original equation. So the very first step is we want to, so I'll put step 1, is we want to swap or switch your x and y. So we're going to do that by switching them out. So where your y is, we're going to put x. Where your x is, we're going to put y. And then step 2 means we're going to solve for y. So if we solve for y, x equals 2y minus 4. I'm going to add 4 to both sides. So I get x plus 4 equals 2y. Just like I did in my warm-up, I'm going to divide both sides by 2. Which means if I swap this around, the 2's cancel, so I get y is equal to x plus 4 all over 2. If I separate these two, there's a little 1 in front of my x that's invisible. This is the same thing as 1x over 2 plus 4 over 2, which we all know can reduce to 1/2 x plus 2, just like we did in our group warm-up.